Wednesday about solving equations. Okay, and we had a rule that we had to follow and we had a goal. Okay, so what was the goal when we were solving equations? Like if I was solving for x, what did I have to do with x? I needed to isolate the variable. And then what was my rule? I call it the sibling rule.
Whatever you do to one side, you have to do to the other side?
Yes. What you do to one side, you have to do to the other. You have to keep it balanced. So what we're going to look at today is we're going to look at formulas or problems that have more than one variable. And this is very beneficial when it's very beneficial for any science class that you have to take. No matter what your major is, you're going to have to take at least one. If you're an education major, you're probably going to have to take a couple. But this is a very beneficial skill for science class. It's also very beneficial when we do linear equations, and we have an example of a linear equation that we're going to do in a few minutes. So this one right here says that we are going to solve for W. So what we want to do is we want to get this W isolated the same way that we would a variable if there was only one variable in our equation. So we're going to follow those processes the same way. So the first thing that I want to do is I want to get rid of this 2L. And so we are going to subtract 2L from both sides. Okay? Now, when we were doing equations that just had one variable, very often we could combine like terms. But P and negative 2L are not like terms. So we leave it like that. That's what we do. We cannot combine those because they are not like terms. And then we are left with 2W. Okay? So then our next step is to divide by 2 because that's what's with our W. So I'm going to divide both sides by 2. And so my final answer is going to be P minus 2L over 2. So if you stop right here, that is completely acceptable to stop right there. Now, one of the things that students look at is they look at this 2. Do you see how I have a 2 or a negative 2 in front of the L? And then I have a 2 in the bottom. Well, students think, oh, do I need to cancel those? And what you have to remember is that this 2 on the bottom, it belongs to the P and it belongs to the negative 2L. So you can't cancel the 2 completely unless there's a 2 in front of the P also. But what you could do, you could write this as P over 2 minus 2L over 2. And then you could cancel this 2. But you still have to keep that 2 with the P. So we could have P over 2 minus L equals W. This would be an acceptable answer too. What you need to understand though is because this is subtraction right here, you can't just cancel those two 2's. Okay? And that's going to be something that comes up when we do square roots. It's going to come up when we do when we're solving the quadratic. So recognizing that when you've got a 2 in the denominator like this, and you are adding or subtracting right here, in order to simplify, you've got to have that factor in all 3 places. Okay? Okay.
Okay. Anybody know what P equals 2L plus 2W is?
Perimeter?
It is. Perimeter of a rectangle. Perimeter of a rectangle. That's not something that you need to know. It's just something that is out there. So this one we're going to solve for H. A equals 1/2 base times height. Any guesses? Area of?
A triangle.
Triangle. Good. It's an area of a triangle. Now, this one right here has a fraction. It's got that 1/2 right there. So we're solving for H. Now, the difference between this one and the one before is that all of these are being multiplied together. The 1/2 is being multiplied times the b, that's being multiplied times the h. So we don't have any addition or subtraction that we're worried about. What we want to do, though, is we want to get rid of that 1/2. And that 1/2 is being multiplied times our b and our h. So when we have fractions like that, what we actually want to do is we want to multiply by the reciprocal of that. So if I have 1/2, what is the reciprocal? Which means I flip that fraction. 2 over 1. Good job. 2, but 2 and 2 over 1 are the same thing. So when I do that, when I've got 2 over 1, my 2's cancel. Okay? I want to make sure that it's 2 over 1. My 2's cancel, and I'm left with 1. Okay? And so that's what I'm going to do right here. I'm going to multiply this times 2 over 1. Okay? And when I do that, my 2's cancel. So I'm left with 2a equals base times height, or BH. And I'm solving for h, so my next step is to divide by b. So my final answer is h equals 2a over b. Now, do you guys know how passwords are case sensitive? Have you ever heard that? Yeah. Like if you've got a capital letter, you've got to do it. I would tell you that variables are too. They're case sensitive. So if you've got an equation that has a capital A in it, and then somewhere else in the equation it has a lowercase a, those can mean two different things. So go ahead and keep that A capitalized. Okay, think of it like your password. It's case sensitive. Okay, can I move on to the next one? Cool. Okay, now this one right here is the one that will give you fits. This will be the one that you're like, Alicia, I don't have any idea what I'm doing. So for here, this is an interest. This is the amount of money that you would have in the bank. And P stands for principal. And we are being asked to solve for P. Very, very consistently, what students will do when they see this, they're like, oh, well, that's easy. I'm just going to subtract this from both sides, and I'll have A minus PRT equals P. Okay? This is the wrong way to do it. You do not want to do it this way. The reason is because I have two P's. I have a P there and I have a P there. So when I solve for this, I've left a P here. And that doesn't work. I haven't solved for P. So that is not the way to do it. So I am going to erase this. And I want us to think about the distributive property. So I'm chasing a rabbit over here. This is a different type of problem. So if I have a 2, and I'm going to distribute that, okay? That means I'm going to take the 4 and I'm going to multiply it, or the 2, I'm going to take the 2, I'm going to multiply it by the x, then I'm going to take the 2 and I'm going to multiply it by the 4. Okay, I would get 2x plus 8. Okay, that's the distributive property. Now, I can do that, but in the opposite direction. That's called factoring, and we will actually spend a significant amount of time on factoring. But what I'm doing in this problem with the P plus the PRT, I need to take that P out. So if I have something like 3x plus 9, is there a 3 in both of these? Okay. If I pull the 3 and put it out on the parentheses, what do I have left inside the parentheses? X plus 3. Because 3 times x gives me 3x. And 3 times 3 gives me 9. Okay? So both of these right here, I've used the distributive property to do that. So here, what I want to do is I want to use that same property to pull out a P. So if I pull out a P, P times what gives me P?
1.
Yes, it is 1. P times 1 gives me P. Then here I've got P times RT. Okay? Now, if you're not quite sure if you did that correctly, what you would do is you would then redistribute the P. So you would say P times 1 equals P. P times RT equals PRT. That's how you know that you've done it correctly, because you want them to stay equal. And students typically do okay once they see that step. That's the step that they miss. That's the one that they're not sure what to do. And in another class, you will do something called inverse functions. And this process is important for inverse functions, when you have to find inverse functions. So it's a skill that you will use in the future. And so you want to be able to do the opposite of that distributive property. You're still using the distributive property principles to do that. Okay? Now that we have that P pulled out, I can divide by 1 plus RT. And I have my answer. Now, if you remember, the fraction bar is a type of grouping symbol. The fraction bar is a type of grouping symbol, so you don't have to have parentheses around that 1 plus R2, because the fraction bar tells you that it's grouped together. However, many students will leave those parentheses in there, and that's an excellent habit to get into. Question? Oh, no, okay, I'm sorry. Okay. So this is one that you might put a star beside that you want to go back and look at again. Okay? Yes, sir.
What happens if, like, so you see where that 3x plus 9 is?
Yes.
And the equation below it?
Uh-huh.
So what happens if you start off with an equation with 3x and then parentheses x plus 3? You understand what I'm saying?
I'm going to write it down, and you're going to tell me if I'm right, what I've written down. Okay, so I start with 3 on the outside of the parentheses.
Yeah, and then another x. No, put the x by the 3 and then...
Outside the parentheses?
Yeah.
Okay.
And then a parentheses, and then x plus 3.
Okay.
How would you solve that one for the way you're doing it now? Or is that like not a thing?
This one's going to be a quadratic, so you're going to end up with 3x squared plus 9x. And so you would be solving a quadratic, which is a different set of rules. And I will give you those tools in about a month.
Okay.
Okay? So it is possible. Okay. Can I move from the screen? Okay. This is what you're going to see in this class. Okay? This is a linear equation. And this is actually standard form of a linear equation. So you may remember that from high school. If you don't remember that from high school, you're completely fine, because all we're doing right now is we're solving for y. But this is what you will use this for the most in this class, is we will take 2x minus 5y equals 7, and we will solve that for y so that we can graph the line. And so being able to solve for a variable when there's more than one variable in there is a skill that is useful. This is a little bit more straightforward than the one that we were solving for p, because you're not using the distributive property or anything like that. So for this one, we are solving for y. And so I am going to subtract 2x from both sides. So I'm subtracting 2x from both sides. When I do that, the dangerous thing for students is they like to drop that negative that belongs to the 5y. Okay? Don't lose your negative. That's one thing that students do very often is they misplace or forget to write down the negative. And that negative belongs to the 5. So I'm going to write negative 5y equals negative 2x plus 7. Okay? Now, my next step is to divide everything by negative 5. Dividing by negative 5. Now, if you left it as negative 2x plus 7 over negative 5, you would be okay. That's a reasonable way to leave it. However, to graph a line, you typically have it in this y equals mx plus b form. And so it's a decent habit to get into to go ahead and split this. So you're going to have negative 2x over negative 5. Then you are going to have 7 over negative 5. Okay? So we would do y equals negative 2x over negative 5 plus 7 over negative 5. Okay? That negative 2 over negative 5, what happens there?
They can't cancel out and become positive.
They do become positive. So a negative divided by a negative is a positive. So this negative 2x over negative 5 becomes positive 2/5 x. And 7 over negative 5 becomes negative 7/5. And this is a linear equation in slope-intercept form. So you might remember this y equals mx plus b from a previous math life. And if you don't, that's okay, because we'll talk about it a lot later. But this is one of the key skills for solving for variables. Okay? Okay. Questions before I move to the next screen? Yes, sir.
When you're setting it up and you have negative 5y equals negative 2x plus 7, what if you put plus 7, yeah, right there.
Okay.
What if you put plus, or just regular 7 minus 2x?
That would be fine. Yeah, that's completely fine. So the question is, at this step, if you wrote negative 5y equals 7 minus 2x, is that still mathematically correct? And the answer to that is yes, it is still mathematically correct from a statistics point of view. So if you're in a situation where you're going to take 147, which is a somewhat of a statistics class, that is how it's written in a statistics class. I don't know why, but they flip the intercept and the slope. If you're doing it linear, then it is going to go back to this y equals mx plus b. But mathematically, you are absolutely right. That's correct. Okay? Good question. Caitlin? Oh, no. Okay. Okay. Moving on. Okay. So now, what we are going to talk about are inequalities. Inequalities. And so, when I talk about an inequality, so we've talked about equations. When we talk about inequalities, there are 4 signs that we deal with in inequalities. Okay? We have the less than sign. Okay? We have less than or equal to. We have greater than. and we have greater than or equal to. Okay, those are our signs. Now, we are going to start putting things in what is called interval notation. And it is another way to write an answer. Interval notation is another way to write an answer. So when we are doing that, I always think it's easier to look at the graph before we put things in interval notation. Because once you look at the graph, you're really able to see where your negative infinity is and when your positive infinity is. So we always want to think about the graph as we're thinking about interval notation. The other thing with looking at the graph is it makes us put it in numerical order, because you're always going to put your answers from least to greatest when you put your answers in interval notation. And if you graph it, then you are really able to see where it is that those numbers fall on the number line. So graphing is super, super important. If I was graphing something when I was in high school that was x is greater than 2, very often I would use an open dot and a closed dot when we were talking about less than and less than or equal to, or greater than or equal to. When would I use an open dot? And I want you to raise your hand if you used open dots. Yes. When would you use an open dot? When there's no, right, when there's no line. So when there's no or equal to, that's when you would use an open dot. When would you use the closed dot? You go ahead. Good. So for less than, I would use, so if this is 0, then here's 2. I'm going to use a different color. Let's do blue. Maybe. Okay, yeah. So I would use an open dot at 2, and then I would go in this direction. That's how I would use my open dot. Okay? Now, for interval notation, instead of using an open dot, we are going to use a parenthesis. Okay? So if you think back to, okay, well, this is when I would use an open dot and go this way. This is when I would use a closed dot and go this way. I would use an open dot and go this way for greater than. And I would use a closed dot and go this way for greater than or equal to. So instead of those open and closed dots, you are going to use parentheses and you are going to use brackets. Okay? So a parenthesis means the same thing as an open dot, and a bracket means the same thing as a closed dot. Okay? For interval notation. So for this right here, for this x is greater than 2, and I did it the wrong way. Okay. X is greater than 2. Here's 0. Here's 2. Okay. I am going to use a parenthesis because it's greater than, and I'm going in this direction. Now, this is not interval notation. What this is right here, this is the graph. This is the graph associated with x is greater than 2. The parenthesis means, so if I use parentheses, that means the number is not included. It's just like the open dot. Okay? It's just like the open dot. If I use brackets, that means the number is included. And that is like the closed dot. Okay? So this is my graph right here. I've got x is greater than 2, and this is my graph. I'm going to use this graph to write it in interval notation. What number is way down here? What number is way down here? Right here. What number is right there? Negative infinity. Negative infinity. So at the very end of my number line, going in the right direction, the right-hand side, I have negative infinity. What do I have on the other side?
Positive infinity.
Positive infinity. Okay? So my number starts right here at 2. It is a parenthesis because 2 is not included. And I'm going all the way to positive infinity. Okay? So the line, this right here, that's my graph of x is greater than 2. That's my graph. The parenthesis 2 comma infinity, that's interval notation. That is interval notation. And that is what we're asking for our answers. But doing the graph helps you get there. It helps you think about it. So the graph is super helpful there. Okay, let's do the next one. So I am going to do the graph first. Okay, so I'm doing x is greater than or equal to 2. So for my graph, okay, I'm going to have a bracket at 2. And I have a bracket at 2 because it's included. Because that number is included. Then I'm going to the right because it's greater than or equal to. So this is my graph. Now I'm going to take that graph. I'm going to erase this because I'm running out of room. I'm going to take this graph and I'm going to use the graph to tell me how to write interval notation. So I'm going to start at positive 2 and then I'm going all the way to infinity. Now, what's the difference between x is greater than 2 and x is greater than or equal to 2? Raise your hand so you can tell me. What's the difference between x is greater than 2 and x is greater than or equal to 2? What's the difference between those two things? Yes, sir.
Well, if it's greater than, it's got to be more than 2.
Okay.
Like it can be, the other one it can be less or all the way up to 2. Have to be there.
Okay, so this one is 2 included in the top one? Can 2 be part of your solution?
I guess. I don't know what you're talking about.
Okay, no it can't. Okay, so on the top one, 2 is not a solution. So if I tell you, you need to pick a number greater than 2, can you pick 2? No. If I say to you, pick a number greater than or equal to 2, can you pick 2?
Yeah.
Yes.
That's the difference, okay? That's the difference between the parentheses and the bracket. That's the difference between the parentheses and the bracket. I'm going to erase my right-hand side. Well, no, let's not do that. Okay. So I'm going to do x is less than or equal to 4. Okay? So I want you to try to graph that on your paper, and then I want you to try and put that in interval notation. So I'm going to give you 60 seconds to do that. So see how far you get in the 60 seconds. Now, when my variable is on the left-hand side, do you see how this is x is less than or equal to 4, and my variable is on the left? Okay? Whenever I have my variable on the left, I am able to, my graph is going to go the direction of my inequality sign. So this, because this is pointing in that direction, that's the direction my graph is going to go. And that is helpful, and that is why when we solve inequalities, we always want to move our number, our variable to the left. That's why we do that. Okay, so I'm going to start at 4, and I'm going to have a bracket at 4 because of the or equal to. That's why it's a bracket. And then I am going this way to negative infinity. So once I've done this, I can write it in interval notation. My infinity sign and my negative infinity sign always has a parentheses, and that is by definition. And to put it in the most understandable form for my brain, my daughter had to tell me when she was 15 why. And it's because infinity is a concept. It's not a number. And so when we are at negative infinity, we can always go one more past negative infinity. So that is why, because we never reach infinity or negative infinity. We're always going to negative infinity. And so that is why your infinity and your negative infinity always have a parentheses and they never have a bracket. So we're going to do negative infinity because that's what's hanging out way down here. And then we are going all the way up to and including 4. We're going all the way up to and including 4. So this is our graph right here where I've got the blue dot. That's our graph. This is our answer in interval notation. Okay? Can I move off this slide? Yes, sir.
When would you actually use the concept of infinity when you're counting?
When you're counting, it's very much, it's used in calculus quite a bit because you're approaching things and you're approaching infinity and you use it in limits quite a bit. When we are graphing, when we're graphing lines, parabolas, any kind of graph, you can always put, there's infinitely many points on a line. And so that is also used in the number of solutions there are to a linear equation or a quadratic equation. In counting, I'm not sure. That's a good question, though. I wish I had a better answer. Okay? I'm moving. Okay, here we go. So, what we are going to do now is we are going to solve inequalities. Solve inequalities. Now, the good news about this is you pretty much already know how to do this. Okay? The good news is we are going to use the same properties. So that's the same goal and the same rule as we do for equations. Okay? Same property, same rule as we use for equations. The one exception, and you definitely want to highlight this, you want to stick it on a sticky note when you're doing your homework. You want to have it. The exception, when you multiply or divide both, that's key right there, both. Highlight, underline, italicize the word both sides of the inequality I'm going to run out of room. I ran out of room. Inequality. By a negative, you reverse the sign. Okay? So, let's do this one, and this will make more sense. Okay? Let's do this one, and this will make more sense. So, I'm going to use the same properties and the same rule and the same goal that I did for equations. So, I've got 3x minus 4 is greater than 8. So, I am going to add 4 to both sides. I'm adding 4 to both sides. So, I have 3x is greater than 12. My next step is to divide both sides by 3. Okay. This number right here, the number that I am dividing both sides by, is that positive or is that negative?
Positive.
It's positive because it's positive 3. So this does not apply because that number is positive. Now we're going to do some more and we're going to run into some negatives. But that's the number I'm talking about. When I divide both sides by a negative or I multiply both sides by a negative, that's when I reverse the inequality sign. So in this one right here, I do not reverse it. Okay? So I divide by 3 and I get x is greater than 4. X is greater than 4. Okay? Now, I'm going to graph it. I'm going to graph it. Even if the directions do not say graph it, it's easier to go from the graph to interval notation than it is to do interval notation without the graph. So I would graph it. So here I've got, there's 0, 1, 2, 3, 4, 5. Okay. I'm going to 4. I'm going to have a parenthesis. I'm using a parenthesis because there's no or equal to. And then everything greater than 4 all the way to infinity is part of my solution. So once I've graphed it, then I can write interval notation more easily. Okay. Can I move off this slide? Okay. Okay. So here, we're doing this one the same way. I am going to subtract 1 from both sides. I'm left with negative 2x is greater than 4. My next step is to divide by negative 2. This is what I'm talking about. Because that number is negative, because the number that I am dividing both sides by is negative 2, that's when I have to reverse the inequality sign. So I've got greater than, I reverse it to make it less than. Okay? This is the number that matters right there. If that's negative, that's when you reverse the inequality sign. Okay? So let's graph it. Okay, so here's my negative 2, parenthesis, okay, so to put it in interval notation, I start at negative infinity, I go to negative 2, questions on when you reverse the inequality sign? Questions on when you reverse the inequality sign? Okay. Now, here we have x's all over the place. Okay? We've got x's all over the place. The first thing that I would do in this problem right here is I would combine like terms on each side. Combine like terms on each side. Okay? So I've got a negative 3x and I've got a positive 5x. That leaves me with 2x minus 2 on the left. On the right, I've got an 8x and I've got a negative 9x. That leaves me with negative 1x minus 7. Okay? So what I did is I combined like terms on each side. Then, the second thing that I would do is no matter what, when you're doing inequalities, move variable to the left. Move the variable to the left. So instead of taking the 2x and bringing it to this side, so instead of subtracting 2x from both sides, I would add 1x and always take the variable that's on the right-hand side of the equation and move it to the left. And the reason that I would move it to the left is because it makes graphing it and writing it in interval notation significantly easier. Okay? It makes it significantly easier. Because if you get your variable on the right-hand side, you can't just switch it like you would in an equation. You've got to switch it and you've got to reverse the sign. Because if I had 2 is less than x, that is not the same as x is less than 2. These two things are not equivalent. You have to reverse the sign again. 2 is less than x. Do you see how it's the greater than sign is facing the x? You would have to rewrite that as x is greater than 2. These two things are equivalent. So you avoid this right here. You avoid the bottom part if you just move the variable to the left. So if you get into that habit, you're going to be fine. So I'm going to add 1x to both sides. And I'm left with 3x minus 2 is greater than or equal to negative 7. I am going to add 2 to both sides. And I have 3x is greater than or equal to negative 5. Okay. So the question is, do I reverse the inequality sign? If you think yes, I do reverse the inequality sign here, raise your hand. If you think no, raise your hand. If you have no idea and didn't vote, raise your hand. I love honesty. Honesty and transparency totally rocks. You do not reverse the inequality sign here. You do not. The reason is because the number that you are dividing both sides by is positive. The fact that my numerator is negative does not affect when I reverse the sign. I do not reverse the sign here because what I'm dividing both sides by is positive 3. So good job. So it is greater than or equal to negative 5 over 3. Okay? Okay. And your graph is going to be a bracket at negative 5/3, which would almost be negative 2, and it is greater than. And it's a bracket because of the or equal to. And there's your answer. Okay, before I let you go, what would you have to do here first? What's the first thing you would do here?
Distribute.
Distribute. Okay, and then you're looking at what you've seen before. Okay, so that's the first thing that you would do there. Okay, quiz 0. When is quiz 0?